Hello friends, my name is Chinmay Deshpande, and in today's video lecture we are going to discuss about solution of simultaneous equation using Gauss Jacobi method. Before that, we'll understand what is linear simultaneous equation. What is a linear equation? It is an equation in one or more variables where each term's degree is not more than 1. That means a variable x may appear but neither any higher power of x such as x square or x cube or nor any product of variable such as x into y may appear. In fact, any linear equation can be put in the form of c1x1 plus c2x2 plus up to cnxn equal to co or c0, where n is the number of variables. The variables are x1, x2 up to xn and c0, c1 up to cn are constants. Let us consider an example which contains unknown values of x and y. X plus y equal to 8 and x minus y equal to 2. So if we determine the values of x and y such that equation 1 and equation 2 holds true, then two equations are called as simultaneous equation as they are considered together. Steps to solve problem of Gauss Jacobi method. While solving the problem of Gauss Jacobi method, follow the steps which are given below. Step number 1. Write the system of equations in the matrix form and perform first partial pivoting. Let us consider three equations: a11x1 plus a12x2 plus a13x3 equal to b1, a21x1 plus a22x2 plus a23x3 equal to b2, a31x1 plus a32x2 plus a33x3 equal to b3. Now what do you mean by partial pivoting? The numerically largest coefficient of x1 is selected from all the equations which are pivot and the corresponding equation becomes first equation. Now leave that equation. The numerically largest coefficient of x2 is selected from all the remaining equations as a pivot and the corresponding equation becomes second equation. This process is repeated till an equation into a simple variable is obtained. From the above equation, we can write x1 equal to 1 upon a11 b1 minus a12x2 minus a13x3. From the second equation which was pivoted, we can calculate value of x2, and from third remaining equation we can calculate value of x3. Let initial condition is x1 raised to 0, x2 raised to 0 and x3 raised to 0 equal to 0. Therefore, we can write a generalized formula as x1 raised to 1. Now what I have done here, instead of writing x1, I have written here x1 raised to 1 equal to this equation, and this equation is same, but just difference is that here I have written x2 raised to 0 and x3 raised to 0, which is initial condition given. Similarly, I have written the second equation here, but just I have written x2 raised to 1. Here initial conditions x1 raised to 0 and x3 raised to 0. Similarly, I have written equation number 3, which will give x3 raised to 1 equal to 1 upon a33 b3 minus a31 x1 raised to 0 minus a32 x2 raised to 0. Means in all these equations, for right hand side we have used initial conditions. With the help of initial conditions, we have calculated x1 raised to 1, x2 raised to 1 and x3 raised to 1. Make the table for iterations. Use previous iteration values for calculation of next iteration and calculate the value till we will get same values for x1, x2 and x3. So generalized formula for rth iteration is given by x1 raised to r plus 1 equal to 1 upon a11 b1 minus a12 x2 raised to r minus a13 x3 raised to r. Similarly, we can write formula for x2 raised to r plus 1 and x3 raised to r plus 1. Now the main difference between Gauss Jacobi and Gauss Seidel method is that in case of Gauss Seidel method, the latest value of x, y, z or x1, x2 and x3 is used to find the next value of x, y, z or x1, x2 and x3. Whereas in case of Jacobi's method, the same values of x, y, z obtained in the one iteration is used for finding the next value of x, y, z in the same iteration. Gauss Jacobi method. We'll solve one problem. Solve the following set of linear simultaneous equation using Jacobi's iteration method. Now the equation is given as 20x plus y minus 2z equal to 17, 3x plus 20y minus z equal to minus 18 and 2x minus 3y plus 20z equal to 25. Now from our steps we have to perform partial pivoting first. Note, always do partial pivoting, means arrange the equation in the following manner having the highest value for all the diagonal elements. As the equations are already pivoted, means check all the values of x. Now 20 is the greater value, as 20 is highest in the x coefficient, so that's why this equation will be first equation. Now leave this equation, check for these two remaining equations and check for a coefficient of y. Now in the second equation coefficient of y is greater, so that's why this equation will be equation number 2 and remaining equation will be equation number 3. So this is equation number 1, equation number 2 and equation number 3. Now from these three equations we can write a formula for xyz. Means from equation number 1 we have to rearrange equation for x equal to. From equation number 2 we have to rearrange the equation for y equal to, and from equation number 3 we have to rearrange the equation for z equal to. So this is the first equation, x equal to 1 by 20, 17 minus y plus 2z. From the second equation we have written value of y which is equal to 1 by 20 minus 18 minus 3x plus z. From third equation we have written value of z, that is equal to 1 by 20 into bracket 25 minus 2x plus 3y. Now let us consider that initial values are x raised to 0, y raised to 0 and z raised to 0 equal to 0. Hence equation 4, 5 and 6 can be written as, here I have written same equation number 4 but it is represented x as x raised to 1, that is first iteration. And here I have written y raised to 0 and z raised to 0, that is initial values. Similarly from equation number 5 we can write next equation, and similarly from equation number 6 we can write next equation. Now from these three equations we can make a table for solution. Prepare a table for calculation of iteration. So first element is x raised to 0 which is divided by a. Then y raised to 0 is b, z raised to 0 is c. First equation is x raised to 1 equal to 1 by 20 into bracket 17 minus y raised to 0 plus 2z raised to 0. So convert this equation in the form of ABC. Similarly we have written equation for y raised to 1 and last equation is for z raised to 1. So this is a table. Initially values of x raised to 0, y raised to 0 and z raised to 0 are 0. So put these values on the calculator. We will get answer for x raised to 1 is 0.85. That is at the end of first iteration value of x will be 0.85. At the end of first iteration value of y will be minus 0.9, and at the end of first iteration value of z will be 1.25. Now same values which are come from iteration number 1, you have to use these same values for calculation of iteration number 2, that is value of xyz in iteration number 2. So that's why here we have written x raised to 1 from the previous iteration will be x0 for next iteration. Y raised to 1 from the previous equation becomes y0 for the next iteration, and z raised to 1 from a previous iteration becomes 1.25, that is z raised to 0 for next iteration. So again we have calculated value for x, y, z for second iteration. So we have to solve these or complete a table in such a way that the values of x, y, z will be same, that is corrected up to 4 decimal places or 5 decimal places depending upon the statement which is given in the problem or question asked. So here in the 10th iteration we will get similar answer. This is 1.0000 which is nearly equal to this 0.9999 minus 0.9999 nearly equal to minus 1.000 and 0.9999 is again related or it is nearly equal to 0.9999. So answer is x equal to 0.9999 or 1, y equal to minus 1 and z equal to plus 1.